All right, hey stats class. We've got quite a bit going on today. I called the title of this Measures of Variability Part 1. And more specifically, these are our goals here. So we're going to describe data with numbers and then come up with a process to identify outliers. So we're not just guessing, and we can say definitively what is an outlier and what is not. So I am using, again, the data from our stat survey where I collected all of your heights in inches. I know we created a histogram on this and we said, hey, that person with a height of 36 inches is probably an outlier. It looks like it doesn't really belong with this data set. And we'll find out if anything else in this data set is an outlier. So if you want to right now, you might still have this stored in your calculator, but if you don't, all you have to do to get there is hit stat and then hit enter. And mine are still in there from the other day. So let's get started. Describing data with numbers. So what we're going to do is find this thing called the five number summary. The five number summary. Okay, so the five numbers that we're going to use to describe this data set are the minimum amount. We're going to find the minimum. We're going to find this thing called Q1. Another thing, we're going to find the median. We're going to find Q3. And we're also going to use the max value. Okay, so let's go ahead and do this manually first. And I'll explain what the Q's mean. So the minimum, I already have this in ascending order. That's really easy to find. The shortest person in the class was 36 inches tall. The maximum value of the tallest person in the class is 75 inches tall. And then to find the median, remember that is the middle number. So since there's 19 observations, we would want 9 observations to be smaller than that amount and then 9 greater. So whenever you have an odd number in your data set, it's pretty easy to find the median. So let's go ahead and count them off. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like this might be the median because it has 9 observations fewer than its value. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got 9 observations greater than that value. So the median of this data set is 67. Okay. So now what these Q's stand for are the quartiles, or like the quarters of the data. So where the median gives you the middle 50%, again, where half is less than that amount and then the other half of the data is greater than that amount. The quartiles reference 25%, and then this one would be 75%. So the first quartile, 25% of the data is going to be less than that amount, and then 75% greater than that amount. And then this is just the opposite of that. So another way to think of that is quarter 1 is the median of the first half of our data. Quartile 3 would be the median of the second half of our data. Okay. So let's continue then. How many observations are here now? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 observations here. So in the middle of this data, that would be 1, 2, 3, 4. And then I'll just kind of put another arrow here. Okay, and then quartile 3. So again, 1, 2, 3, 4. So this would be quartile 3. This value splits up this part of our data. So quartile 1, that would be a person that is 62 inches tall, and then quartile 3 would be a person that is 70 inches tall. All right, let's get our calculators out. Hey, so hopefully you all got a chance to do this in, or get your calculators and get the data in. So again, on the calculator, if I go to stat, just to verify, then you hit enter. This list should be in list 1. If it's another list, that's fine too. I'll show you how to get to that. So anyhow, so I can quit to get out of the lists. So we are going to find the five number summary on your calculators. It's not too difficult to do. Hit stat and then scroll to the right to get to the calculate column. Okay, and we are working with one variable. The variable is height. So we're going to go into this option, just hit enter. We're going to calculate one variable statistics on list number 1. If you put this in a different list, you could just hit second. You could hit second, and then you see the L's here. Those will reference or calculate statistics on different lists. Again, mine is just list number 1, so I'm going to leave it there. We only want to count this list one time. Calculate. And it's going to bring up a lot of stuff. So like you remember what X bar means. So the average height of a student in our class is 64.9 inches. We don't need any of this for now. Just scroll all the way down and there's your 5-number summary. And we can verify and make sure that we got the same things as our calculator. So the minimum value again was 36. The first quartile is 62. The median being 67. Third quartile is 70. And then the maximum value, the maximum height is 75 inches. Okay, so that's all well and good. Now what we need to do next is plot this data. We're going to plot the 5-number summary. And the plot for a 5-number summary is called a box plot. Or sometimes you'll see it called a box and whisker plot. Box plots are super easy to plot. All we need to do is start with the minimum value. Or maybe we can create like a little scale first. So let's create an axis down here. Okay, and we'll range from 36 all the way up to 75. Awesome. Hey, so I'll just start here at 35. That would be 40, let's do 45, 50, 55, 60, 65, 70, and then 75. And that'll get all of our data. I made that way longer than necessary, and that's going to be okay. Hey, so this box and whisker plot, it starts at 36. So we just make a tick mark at where it starts. So this first tick mark is going to represent the minimum value. And then I know I just kind of referred to this as a box and whisker plot. So to connect the minimum amount to the first quartile, that's called a whisker. So it goes from 36 all the way up to 62, so around right here. Okay, so that first quartile is going to be the start of your box. Here's the whisker that connects these two things. The box is going to end at the third quartile. So my box goes all the way up to 70. Okay, cool. And then my last whisker goes from the third quartile to the maximum value. So I'll just do this. Okay, and one last thing is the median goes inside of your box. So the median of 67 looks like it would go right around here. Okay, so that's a pretty weird looking box and whisker plot because there is an outlier. Here I can label these things for you real quick. So we got the minimum. This value corresponds to quartile 1. This value corresponds to the median. The end of your box is quartile 3. And then again, this is the max. Okay, so we want to make another box plot that does not include the outlier. And I'll show you how to identify outliers. So finding outliers. Finding outliers. Okay, the first thing to do in trying to find an outlier is to establish something called the interquartile range. And that is abbreviated as IQR. Again, that is the interquartile range. And this is just quartile 3 minus quartile 1. The IQR is quartile 3 minus quartile 1. So if we kind of continue this, quartile 3 again was 70. So 70 minus 62. So our interquartile range is 8. Okay. So what we're going to do is add some fences to our box plot. Anything outside of those fences is considered an outlier. So here's the rule for it. First, we'll construct the lower fence. The lower fence. Okay. And so what you're going to do to do the lower fence is quartile 1, the value of quartile 1, minus 1.5 times the IQR. The lower fence is quartile 1 minus 1.5 times the IQR. So quartile 1 is 62. So it's going to be 62 minus 1.5 times 8. Again, the interquartile range is just the length of your box. So 1.5 times 8 is just 12. 1.5 times 8 is 12. 62 minus 12 is 50. Okay, so now that we have our lower fence, we're going to plot that on our blocks plot. We have a lower fence at 50. So I like to just make a dashed line and then just put LF there. So anything less than our lower fence is an outlier. So if we go back to our data, anything less than 50 inches is an outlier. So it looks like the only outlier so far is 36. Okay, now we'll do the upper fence. The upper fence is calculated almost the same way. It's just, different. The upper fence is quartile 3. And instead of subtracting 1.5 times the IQR, we are going to add. So we're going to add 1.5 times the IQR. Okay, so quartile 3's value is 70. I'm just going to do this all at once here. 1.5 times 8, again, is 12. So we get 82 for our upper fence. So if this was 80, 82 is probably going to fall right around here. Here is your UF, the upper fence. Anything greater than 82 would have been an outlier. So we're able to much more accurately answer that outlier part if we were describing this distribution. There is one outlier, and that outlier is certainly the person that is 36 inches tall. I doubt they actually are 36 inches tall, but that's how they answered anyhow. Okay, is there anything else I wanted to do? Yes, there is. Hey, so go back to your calculator and go to stat plot. So again, you would just hit second and then stat plot. I have this one on as a histogram, so let's go into this plot. And we're going to change this to a box plot. Okay, now you should see two different types. This one has some dots on the end. Those represent outliers. Okay, this one, this box plot doesn't mention outliers at all. So let's go ahead and pick the one with outliers. Just hit enter. It's going to mark our outliers as this kind of square looking thing. You can change that if you wanted to. I think we have everything we need though. Just go ahead and hit graph. There's my box plot and it looks pretty good. Maybe hit zoom stat if yours isn't showing up. Zoom stat, hit enter. So my scale is already the same. Fantastic. So here's my box plot. Again, we got the minimum value, the first quartile, the median, the third quartile, and then the maximum value. And this dot way over here is an outlier. So it gives you a much more clear picture of the actual data set, excluding that outlier. You can probably see it looks similar to the one that we created by hand, but the minimum value here, where the whisker starts, it starts at 58 instead of 36. And that is a much better way of creating box plots. So if we were to do this again, you would want to define the outlier first, make a dot for that outlier, and then start the box and whisker plot at the next smallest value. Or even in this direction if we had a large outlier instead of a small one. All right, so that's definitely going to do it for this video. Thanks you all for watching, and I'll see you in class sometime, maybe.